Hi there, not sure what happened other than I reached the 15 minutes, which is the it's the limit for my unpaid version, but I have a paid version, so I'm not sure what's going on. Anyway, I know this is an intense video, a little slow, if need be, speed it up, but it's really good at breaking down the parts of the eye and describing their function. So let's continue.
Layer is the iris. This is a circular structure with an aperture in the center called the pupil. The iris is the component of the eye which gives you your eye color. It has two arrangements of fibers which control the size of the pupil, circular fibers and radial fibers. The circular fibers make up the sphincter pupillae muscle, which is innervated by the parasympathetic nervous system. Activation of this system causes constriction of the pupil, which thereby limits the amount of light that can enter the eye. The radial fibers, on the other hand, make up the dilator pupillae muscle, which are innervated by the sympathetic nervous system and cause dilatation of the pupil, thereby increasing the amount of light that can enter the eye. I've highlighted the iris in green and sliced the eyeball in half. Let's rotate around to view the eyeball in section and view the relationship of the iris to the other structures we have covered so far. The inner layer of the eye consists of the retina, the light-detecting part of the eye. The retina itself is comprised of two cellular layers, the neural layer and the pigmented layer. The neural layer consists of photoreceptors, the light-detecting cells of the retina. It is located posteriorly and laterally in the eye. The pigmented layer lies underneath the neural layer and is attached to the choroid layer. It acts to support the neural layer and continues around the whole inner surface of the eye. Anteriorly, the pigmented layer continues, but the neural layer does not. This part is known as the non-visual retina. Posteriorly and laterally, both layers of the retina are present. This is the optic part of the retina. The optic part of the retina can be viewed during ophthalmoscopy or fundoscopy. The center of the retina is marked by an area known as the macula lutea. It is yellowish in color and highly pigmented. The macula contains a depression called the fovea centralis, which has a high concentration of cones, which are the light-sensitive receptor cells, which function best in brightly lit conditions and are responsible for high acuity color vision. The area that the optic nerve enters the retina is known as the optic disc. It contains no light-detecting cells and is therefore referred to as the blind spot of the retina. The central retinal artery enters at this point, and its branches are visible at this point when viewed during fundoscopy. There are a few remaining structures to discuss to cover the basic gross anatomy of the eyeball. There are two fluid-filled areas in the eye, known as the anterior and posterior chambers. The anterior chamber is located between the cornea and the iris. The posterior chamber is a small chamber located behind the iris and anterior to the lens and suspensory ligaments. The two chambers are continuous with one another by the pupillary opening. The chambers are filled with aqueous humor, which is a clear plasma-like fluid that nourishes and protects the eye. The aqueous humor is secreted first into the posterior chamber and flows into the anterior chamber via the pupil and is then absorbed into the canal of Schlemm, also known as the scleral venous sinus. This channel encircles the eye, lying at the point between the cornea and the iris. You can see this highlighted in blue on this model. If the drainage of aqueous humour is obstructed, the intraocular pressure will rise, a condition known as glaucoma. The lens separates these two chambers from the vitreous chamber, which fills the eyeball with a transparent, gel-like substance known as vitreous humour or vitreous body, extending from behind the lens to the retina posteriorly. So that's an overview of the gross anatomy of the eyeball. In the next tutorial, we'll take a look at the vascular supply.
Okay, so that breaks down the parts and gives more detail than you really need to look at, because the detail you really need to look at is here. Okay. Now, when the light comes in, there's a principle called refraction. And refraction is just the, one moment. Refraction is the bending of light. And as light bends, it will, there we go. As the light comes in, it is bent first by the cornea, then it's bent by the aqueous humor, then it goes through the pupil. Realize the pupil is just a space, so it's an opening. Then it goes through the lens, and the lens will change it, and then at the end, it will then again be bent by the vitreous humor. So although it doesn't show, it can be bent here, and then bent greatly here. And it actually goes upside down. So I don't really like this picture, but they didn't ask me when consulting it. Okay. And then the image is shown upside down. And then the brain just puts it right side up, which I think is fascinating. Okay. So refraction is the bending of light based on the properties of the substance that it goes through. Then when it comes into the eye, you have the property of convergence. Convergence is bringing the light to a focal point. And this is sort of how your eye focuses from a distance. When the subject is from a distance, they come in pretty much parallel and they're not bent as much. And this is why your lens doesn't have to, if it's lost its elasticity, you can still see from a distance, assuming you could see from a distance before. Then as you get older, as you're reading, the lens is bending the light more because it's thickening, and that causes convergence. The video talked briefly about the constriction of the pupil. It's controlled, the constrictor is controlled by the parasympathetic, and the dilator is controlled by the sympathetic. So the idea is when you're scared, your pupil opens up wide so you can take in as much light and as much as possible. Okay, when we look at receptors, there are two types of receptors, the rods and the cones, and they're based on their shape. The rods are rod-shaped, and the cones are cone-shaped, which is kind of cool. So there's more of them in the peripheral with the rods, and they see better in dim light. So because of that, they're very useful in night vision, but they are not good at distinguishing colors. The cones are good for color. They're concentrated, they're colored, and they are for sharp vision in bright lights. And this is why sometimes at night you have difficulty seeing color, because your cones aren't firing. Okay. When the impulses come in, your eyes actually will overlap the image, and one will fill in for the other. Half of it goes through one eye and half goes to the other, and then it goes through something called this optic chiasma, where the information flips and goes to the opposite side of the brain. So it's actually quite fascinating how the brain interprets the images. Okay, and that is the end of vision and the end of the nervous system. That was a lot of information. Go back, take a look for it, look at it, go through the chunks.